A lot of times we do use cheap calipers. I had a pair of really nice new calipers many years ago that got stolen at a shop, and the nice vintage Toyos are better. I haven't seen a real advantage in the Fowler over some of these other cheap ones. SPCs, a lot of them, because they're pretty much the same thing as near as I could tell anyway. And big point in that is we have a measurement we need to take where I need to know these little ends as they get thrown around the shop, and they shouldn't, but unless you have your own pair that's strictly your own pair, absolutely pristine and nobody drops them, and if you do drop them, you know what you did. These get bent up, beat up, and these ones are nice and new like they're supposed to be. Yeah, we'll go grab some of the ones over by where we're going here in a second anyway. And where did I set my flange? I was working. I just got through cleaning the flange by my foot. Yep. Okay. And we will need another thing too, but I'll just come back and get it. It does not have to be continuous what we're doing. We're making a flange for a U-joint. This is a flange-style U-joint. There's another name for these. They call these companion flanges. And it just bores in a little ways to center up the flange. And these will generally, there may be a metric series, but they're generally an inch series. And like this one here is not measuring what I would have thought at all. Which, does that mean this caliper is that far off? Nope, nope, it was just, see, you've only got 80 thousandths that this goes down. So what it was I was actually below center. And I was doing that because right there I'm coming up 47, 49. That's what I would expect is a 750-ish measurement. The reason why I try to go below center most of the time is I try to, the same as these get bent, I try to get and use this large flat area with measuring with calipers as much as I can. Because even your best calipers, again, this little narrow area here where it gets into places, that's the part that gets damaged. Now again, we just pulled these out. These are new. And these will work if you have 1 or 2 thousandths press, where you actually have to tap it in or suck it in a little bit. They'll work if they're 1 or 2 thousandths loose. That little bit of run out is not a big deal. The U-joints generally will have 20 thousandths of side movement in them. Not supposed to when they're new, but sometimes new they'll have 20 thousandths. Worn, you'll see more than that. They somewhat self-center if everything's working right, but the closer you can get the flange, the better it is, period. Now, if we look on the drawing here, you'll see that the drawing says undercut for tool radius clearance, and the original piece was that way. And it really doesn't matter what this angle is as you're coming into it. It's just that you bore enough deeper than the face so that that radius is not stopping the corner of this piece right here, because this is only just a little bit. And you want to have also, as you see, this is a 16th, it's 62 thousandths deep. Well, that 62 thousandths has got to be less than this here because you want the big surface to be bolted up and seating. You don't want it just setting on this small edge, and then as it tries to rotate a little bit back and forth, it'll wear that edge off before long, and then you have it loose and the bolts are moving and then everything else gets torn up. You want the face to be against the face, which is inset. So to do that, we need a tool, and actually this boring bar here that happens to already be here will work good. I don't have an air hose. Our air plumbing is something that's a problem in here. I have a big air compressor. We bought lots of lines to go down the walls, but we haven't actually got them in yet. So we share a lot from one place to another. Sometimes I do it the old-fashioned way. It works. Not my favorite, but it works if their chips aren't too bound up in there. Ah, I forget. Are these inch or metric on this one? Yeah, we'll see here in a second. I don't know. I think that one is left-handed. Yes, it is. And what I want to do is I want to put in, so we don't have to go as deep as we would otherwise, I want to put in a smaller radius insert. Okay, so we're going with a smaller radius. We have a chip breaker on top there. It's a clamp chip breaker. Now these, very seldom do you use them for their full chip breaker capability, which would be to put them out near the edge and they make a separate chip breaker. Most of the time you just set them back and they end up being more of a clamping shim to hold stuff down. That was left-handed so that it sucks everything in as it tightens. We don't need these here right now for multiple reasons. One of which we're not working with them. There's another name people, because we do have a lot of dirt here, a lot of miscellaneous, we do mechanic work too. There's a name I don't really, two names I've heard for shops similar to this, and as the shop is getting dirtier and dirtier, it's looking more like those shops that, one of them is a junk shop and another one is a butcher shop. We're definitely not a butcher shop because we don't do just crude, out of tolerance work. But sometimes we do rough work that doesn't need to be accurate. The place where people really get against that is people that have been 100% tool and die, plus or minus 1 or 2 10,000ths on every drawing they've ever seen, and they never saw anything where there was a tolerance given and you had to have it done within a day. I've worked with some of the tool and die people that have done both. And they're pretty cool. Other tool and die people can be hard to work with if they've just done tool and die and don't understand. Sometimes it just don't matter. At this point, this does sort of matter. And so one of the things we're going to do is check our calibration on this micrometer here. And you can't really see it. This is not a Chinese mic. This is a Polish mic. It's an 8-inch. I came close to buying a full set of Mitutoyos because I bought some for a customer who wanted me to outfit them with micrometers, and I outfitted them with micrometers from Mitutoyo all the way up to 60-inch. And I thought about, while I was doing that, doubling up and getting a set for myself. But you know, it would have taken a lot of area to store them. And instead of getting the mics essentially with my profit from selling the first ones, where I'd have them for close to half price, I would have actually been not that good at this point, even at that, because trying to keep them. There's a lot of boxes. That's most of a pickup bed full of micrometers. It was a bunch. So we will end up using that, and here's what we're going to do. We're not, because even if this is accurate, let's say we check this against our standard. Let's check our caliper against our standard, and that's showing a few thousandths off. Yeah, that's showing a little bit off against the standard. But the other thing is, there's nothing that guarantees that this lines up with those. Even on your better, where this way we have a micrometer and we can come in and we can measure on the caliper here. And it's measuring pretty accurately off, but not exactly. And what I really want to do, since, well, I put that at the wrong, I put that for the standard. I wanted to put it at the size I want to be at, and then I'll just make this a 0 at that point, because I can set that at a 0. So I think we had, yeah, 7 and 750. And I set this, you have 8-inch standards, you have a 7-inch standard. And I use the 8-inch standard because it's closer to the size that we're going to. So we'll set the mic there. But I'm not even going to really be at the point of measuring it yet. We still got to get set up here for our cut. Now you can do this another way too when you've got a short cut like this. And I'm coming back, giving it that precise, some kind of an angle. And we did not finish the outside to size yet, so I don't have it to reference off of. So, okay, we will just pick a spot somewhere in here where we know that we're far enough in that it's not a problem. And we are going to, what's wrong with this is the one I want to move. Okay, so I'm going to go in just a little ways, make a scratch, come in 20-ish thousandths, face across it, and we'll see what we've got. Anyway, the point I was starting to make here is sometimes when you're doing a part like this, what you'll do, instead of having this at depth and coming in your other 1/16 of an inch, you'll just leave this part extra thick. So if you left this part an inch thick instead of a half, and you actually bored it, now we can get in there with an inside mic, a telescoping gauge, a bore gauge. We can get in there with all kinds of tools that are easier to deal with than, there really isn't much else other than a caliper as far as inexpensive tools that fit in there. So and we could have done that easily on the other one, where these are for a rush job. But this one here, I decided to take it closer to the 4-inch to start with by sawing it a little bit closer. So it didn't have as much material to take off in the first place by the time we hit the lathe. And if we're going to do it this way on one, we might as well do it this way on two of them. So I'm going to come in there and I'm going to 0 my depth. And then I'm going to peek in here a little bit. I think I'll just take 10. We'll see how that works for starters. We'll face on across it. Now that's a lot of area that we're taking with that angled cut. And we've only got a 1/64th radius, so we don't have a very large radius as far as turning on the other part. And I forgot to stop and measure that when I started. Measure it and set it. When I'm talking and showing things, my mind doesn't always do as well. I do get distracted. It's a lot easier just to show a person stuff than it is to try and make it clear to everybody that might be viewing. And it looks like we're going on the slow side. On the other hand, it's cutting nice and not causing us problems. We don't have that much material to take off. Another thing you can do with this is if you're only fitting it to one flange, or if you have a new flange, it's not bad, is you can just put it 10, 15 thousandths undersize and then just take 1/1000th cuts at a time, just slowly till the flange just starts to move in. You don't really need to, you just need to know that it fits, especially if you're just fitting it to one particular flange. And while they gave me this old flange and a really beat up drive flange for the other unit, which they were planning on using until they found out it was the wrong shaft size. So I don't know if they're going to use a new flange or not. This U-joint flange is not that bad, but the other flange that they had was pretty nasty. Not taking any kind of a real measurement yet. 7,366. I'm going to go faster. This is where you get hurt. Holding on to the chuck. Machine running. Yeah, you could. So I'm going to come out a little more. And I'm going to set that to a 0. So is that too fast? Or was it just the fact of where I was plunging in? Definitely was making sparks. Oh yeah. And not taking as much time. Yeah. Both. Okay, I am going to measure that, start setting where our diameter is. And since we have a 1/64th radius, that says it's 7,431, which we don't have that exactly where it is yet anyway. I come back here to my 0 again that I was at. I kind of like to set these at the actual number. Sometimes setting them to just a point, what did I have? 431?
Sounds right.
Check it again. I think I was looking at the big numbers here. I knew it was a something 1. It's still on 30. Yeah, 431. Okay. So, that being the case, we can come back here. We won't be precisely there, but let's come on back to 650 anyway. So we can cut the rest of this out. We could cut it out with a different tool also, but we'll come back to 7 and 650 so we can get this spacing done first. Yeah, probably a little fast for what I'm doing there. We compromise a little bit. We compromise a little bit. So we're at 450. Let's just try 280 for fun. There's wonderful calculations for surface speed and good starting points. But when you buy lots of surplus inserts and you're not really sure what the grade is anyway, it doesn't matter. I've bought quite a few inexpensive inserts. I've bought some moderately expensive ones. I've never paid expensive prices for any. I have bought some that would cost a lot if you were buying them in a catalog, but little hook thing, whatever. Okay. And yes, this stuff up here, this is dangerous, having that stuff above the lathe chuck where it can come off. Could hit into what you're working on, get launched. It is a bad habit, leaving stuff up there. And this lathe is definitely not made for that. It's got a flat top, it's newer lathe. The other lathe is somewhat made for that. It's got a little dish. And old lathes that I'm used to had a real dish. A lot of times shops would build a tray in there with a 4-inch high side so you could keep extra tools there. Because junk shops like this, you don't have enough room. You have to collect too many things to do the variety of stuff that you're expected to do to be able to keep them all super neat and clean. You have to be a dedicated shop to dedicate to one specific little area to be able to have so few tools that you can be as clean as would be ideal. Or if everybody watched, subscribe, you got to be watching obviously, but subscribe, donate millions of dollars, whatever else you got to do, so that we were the best. Then we wouldn't have to worry about this because we just keep adding on stuff, buying new machines, and make everything would be pretty. There would be no lost ugliness, nothing. We could have I mean, yeah, we'd have the paint on our lathes it'd be polished pretty. Not just paint, it would be good. It would be pretty. Stringy chips. That's one of those things that's a danger, more so than some other stuff again. They get caught up. If you do use a chip hook the way that the manufacturer tells you not to use it, caution, stop spindle before using this tool. Pretty much nobody does that, but they write that on there because they don't want to be liable. But the real concept and value of it is that you can reach in there while the machine is running and get nasties out of your way. That's really building up on the feed shaft there. So, point with that is, don't ever give these things a death grip. Because if it does want to go away from you, let it go. Just let it go. Now, I've got 50 thousandths there. We are going to be on another cut for our final. I see Bert did something else here. He was talking about his bore size. You see where you drug back through?
Yes.
That was not the best plan. No. It won't matter. That will hone very good. You were using 2 course of a feed for this. You were doing production boring yet. You needed to slow your feed down. Awfully coarse. But fortunately, since it's a fair amount undersized, and I said that's good, it will hone very nicely. And we do honing a lot of times because it's not worth risking what it takes or the time it takes to bore something and make it perfect. You just hone it. The hone will take care of a lot of little problems. What I was doing there was going a little deeper than I wanted to, so that I didn't have that time that it was setting there with the chips not clearing out, so that I'd keep my insert in good condition. And now I will take my 62 thousandths final pass across this. If we had the inverter on it, we'd spin the speed up a little bit more right here and keep that shine in it. But if we look at it compared to the factory piece, nobody really cares. I don't mean how the factory piece was when it was made. I don't know what that was like. I'm talking about how the sample piece is at current condition. Okay, so now, go ahead. Didn't really like the way it was around that shaft. So, now, when we come back here, And we were at 650. I'm going to bore it at 698. It's close enough to 60. And I'm going to just turn it by hand. I could do a feed, but I'd rather just do it by hand. That way I don't have to worry about my stopping too much. And I'm going to go a little bit deeper because I want to go deeper there anyway. So now, my position I want to be at. I guess we're close. Yeah, it's going to tell me I got quite a ways to go right now. I have got 89 thousandths to go according to that. So, for all of my making a number there, I guess I'm going to go back to 0. This is simpler for the way we're doing this now. I hit the wrong button, didn't I? Let me just do that. Ah, that's a little strange. Things I don't know about that. Did I hit the wrong one? No, that's the one for the diameter. Okay. Okay. Okay, whatever. Said we wanted to go 89, so I'm going to be careful and take some, but not all that much at all. I'm going to go 40-ish. It said I need to go 46 yet, which is about where we were. So instead of going 46, I will just again zero it. Hopefully that didn't mess up my other number. It's okay. And I'm going to go 23. And that says that I need to go another 24. So I'm not going to reset it. I'm just going to go to 24. put me to 47-ish. And I was actually moving a little bit where I might need slightly more than that. But we could pick it up too. We're going to go in a little deep and let it squeal some. So we get below that radius. So now, uh-oh, measurement says we got nothing. That's what it says. It says we got nothing. Well, a half. Nothing plus a half. Now what do we do? Okay, now what we do need to deburr this too before we go in there. I don't really want to mess with my tools here. I got a deburring tool up here on my junk storage shelf that I shouldn't be using. I guess if I go far enough, I'll teach myself some things. There's one there, yeah. I was also thinking about just grabbing a bar of carbide. It works real good for a fine deburring too, because we're not trying to take a whole bunch off. But I have found with these that they don't work if you don't chamfer it at least a little bit, even as little as that is. And I just didn't want to change the tools. We never did get an air hose over here, did we? Oh. I just didn't see it. You had the thing blowing off, so yes, I didn't look for it. Compressor's off. Which is okay. But I can tell the low pressure. So, now, the moment of question. Do all the numbers mean numbers? I would say it's still slightly tight. So I'm going to trim just a little more. Regardless of what everything else says. That is the piece we're supposed to fit. And we will go just a little more. I didn't like the way that chamfered, and I don't really want to set a tool in here. Just a carbide insert will work. Some of the techniques and things man does, there is an art to a lot of this stuff. And it's not all just a definite do it this way, which is what makes it hard. You tell someone, well, do it like this, and then it doesn't work. And they're like, what's wrong? And there might be 20 different solutions. And if you tell them one and it doesn't work right away, they're aggravated. If you jump right in and you just take over to try, which you may quickly narrow it down to 3 when you see how the one reacts. And now we're down to 3, so now we can try it, and that's a lot quicker than the man that doesn't know, and he's got all 20 of these different options to try. There's just an awful lot of stuff that is a little finicky, and that is just about there. I'm sure that that would suck in. Oh yeah, I like that. That's just the way we like them. It just taps in and keeps it balanced. But it makes me wonder the way that that fit and about how much I had to take to get that if my standard is wrong. Since the standard was measuring wrong there, just because you have a standard doesn't mean it's right. And these have been loaned to other people. This particular mic. I was going to grab a different set of mics that I had that I know have good standards and good mics, but damn it, they're not Polish made, they're not US made, and I didn't want to show them on the video. And I don't have a good Japanese made one in this size. Or I might have a individual Japanese one without a standard. I bought some of them. I came so close to buying the full 12-inch set that I wanted and just never quite did it. I'm getting to where we're doing more and more stuff in that size range that does need to be. Usually the bigger you go, the less accurate it needs to be, so that helps you a lot. But I'm getting more and more in stuff where, well, it's like everything you buy. But then where do I put them? Oh, which 2200 reamers that I don't need am I going to get rid of so that I can store my good mics that have to have a really good place? I don't know. I don't know. Well, there's other things to do on this too. It's going to need some holes drilled in it. We need a key put in it. We've got to trim the outside, and while the outside is supposed to be 8 inches according to our drawing, the only thing that really matters is that it's running true and that we don't get rid of the lip that's there. So, yeah, that's should work. So Bert went ahead, prettied up the outside. He'll knock a couple regular chamfers on there in a second. I went ahead and compared my Chinese mic that I do trust and my other standards, and they all confer the same. I think the reason I was coming up tighter than what it felt on the flange, and I don't think that flange is too dirty. I had wire wheeled it. I think it was a matter of just my pressure on the calipers. You'll get that too. It's a really, I used to do a little, I think a little more accurate on these when I was doing them all the time like this, using the calipers for a transfer mechanism. And I haven't done that for quite a while. That's an art. That part's an art. And I think I was just off in my art by that 0.02 of an inch, which kind of surprises me. I really expected to be off by maybe 1, but 0.02. I mean, John. Oh well. Yeah, this is the one that we're supposed to be duplicating. You can see it was pretty rough there. And this whole flange, at some time, the piece of machinery that this drives is pretty well used up, and they probably had it apart a few times, and this has been sledgehammered to get it on in the past. You can't fully see it, but this flange is bent back from sledgehammering. You can feel it right there, Bert. Yeah, I mean, it's terrible.
Oh, wow.
Oh yeah, it's bent back a 1/16 of an inch. So when you only got a 1/16 inch to align it, and part of it's bent back that far. The big reason why they wanted us to make new ones, though, keyway was the right size. The bore on this is a 2 3/4, and their new machine uses a 2 5/8. So they had suggested, if we wanted up to us, we could weld this up to get them one quicker and then make a second one. And I said, no, we're setting up to make them. We'll make 2. Now, another thing, though, that we are going to do a little different, they had one set screw in here over the keyway. And I think this was probably a flange that was originally thought of for a heat shrink onto something, in which case you wouldn't even have one over the keyway. You might, but normally you won't. And anyway, we're going to put in two set screws because it's better. The shaft size is under the 2 5/8, so it is meant for a slip fit. And we're going to go for 2 5/8 to 2 6/26 is our tolerance for our bore size that we're going with. Their shaft is measuring 2 6/23 1/2. So it's got 1.5 thousandths clearance is what it's got if you're on the 6/25 side. And Yeah, usually both the shafting and the coupling for a slip fit have a thousandths to 2 thousandths clearance both ways. And but the single on the keyway, it just can rock and get torn up too quick. And you could see that too. Besides this having some sledgehammer marks, here's some removal marks. You could also see where the bore, when it was on the correct shaft, the bore is smaller there than it is out here. And it had been moving in the hole. And so we'll just make them a nice one. Doesn't have to match the sample part, you know. It's okay if it works. You don't have to match it. That cracks me up sometimes when I do see things that have been matched to a worn part and they actually made them to match the worn part. It's okay. Not the way I would have made it, but okay. It's what the customer asked for. So another thing we could have done for measuring that flange and getting it more correctly is we could have, just like these are pin gauges. And this one here is it says mismatched, which it's not anymore. We had them all mixed up at one time. It's a good experiment. The ones that weren't labeled on the pins on the outside, I had people clean them off and mic them and find the holes. And good experience for someone. This is a minus set, by the way. They make these, they'll normally be like 2/10,000ths of an inch smaller than the normal size. So you know these ones, if you're checking your size, will just go in the hole at that size. And a plus set, which is the other set I've got, will be like 2/10,000ths of an inch bigger than the labeled size. Anyway, for measuring those, that U-joint alignment, we could have turned some different diameters of piece and faced it back with a little taper so it would fit in there nice and get the ones that just fit in there, so you know, have a variety of them to pick size. Then the last way that we could do it, but it's not practical today because this is not 2375, this is 2024, is we could use our pocket laser computer coordinate measuring machine made by Vivor that they'd send for us for free, and we'd do a review on it, you know. But since it's not 300 and some years from now, no, old ways.